All right, let's work on question number 3 in topic set 10 in Chem 11. This is a question about intermolecular forces and how the intermolecular forces will then affect properties of the molecules, for example, boiling point in this case. So we're asked to consider a series of compounds and we're asked to see which of those compounds might have the boiling point that's closest to argon. So the first thing to think about is to consider what argon is and what kind of forces are involved in argon. So argon is a noble gas. More importantly, it's a nonpolar molecule. If it's a nonpolar molecule, then the only type of intermolecular forces that exist there is the London dispersion force, or LDF. The nature of that force is that it gets stronger as the molar mass of the nonpolar molecules becomes higher. So in this case, argon, if we look at the periodic table down here, has a molar mass of about 40. So if we want to find a compound that has a boiling point close to argon, we will need to find another compound that only contains London dispersion forces in its intermolecular forces and has a molar mass of around 40 grams per mole. Let's now take a look at our choices. The first molecule is Cl2. Cl2 is a nonpolar molecule. We know that because it contains the same atoms, Cl and Cl, so that's going to be nonpolar. So it's going to have LDF as its main intermolecular force. The molar mass of Cl2, based on the molar mass of chlorine right here, it's going to be about 71, which is not close to argon, so this one most likely won't be the answer that we're looking for. Let's take a look at HCl. If we look at HCl, I've provided the electronegativity table right here just as a reference. H has an electronegativity of 2.1, Cl is electronegativity of 3.0, so the difference in electronegativity is 0.9, which means that the HCl bond is polar. However, HCl doesn't have hydrogen bonding because the electronegativity difference with Cl is just too small in order for it to generate the strong dipole that we have in hydrogen bond. So in this case, we have a polar bond, but not as strong as a hydrogen bond. That means we have a dipole-dipole force as our intermolecular force, which is not London forces. Because it's not, then this wouldn't be our answer either. Let's take a look at F2, which is our next molecule. This is a nonpolar molecule, same two atoms, and so it has London forces as its main force. The molar mass of F2 here in the periodic table, each F is 19, so F2 would have a molar mass of about 38 grams per mole. And that's actually pretty close to the one that we're looking for, which is 40 grams per mole with LDF. So at this point, I would think that F2 would be the answer unless we find something that's even better. So let's take a look at the rest of the molecules that were given. The next one is NaF. That, as you can see, is an ionic compound because it has a metal and a nonmetal. So then the interaction between those would be an ionic bond, which is not London forces. And then the last one is HF. This one has a difference between H and F being a polar bond, but because fluorine is the most electronegative element, this bond between H and F is so polar that this interaction is much stronger than the standard dipole-dipole. And this is, of course, what we call the hydrogen bond intermolecular force. And so again, that's not LDF. And so once we look at all of these molecules, we see that the answer to our question must be F2. So F2 and argon should have fairly similar boiling point.